Imagine you are the captain of a ship heading for a safe harbor set among some dangerous rocky cliffs 10 kilometers away. You currently know your exact position and the heading you need to set for the middle of the harbor's entrance. But the fog has come in and you can only see a few meters ahead. Hence, you will need to steer your ship using the compass only. The mouth of the harbor is about only 100 meters wide, and you have to set a course through the middle of it. Calculate the largest error which you can make in the angle and still arrive in the harbor. Second question, assuming you are 10 kilometers from the entrance and the error made in the bearing is theta degrees. Find the error made at your arrival for theta equals 0, 1, 2, 3, 4. Illustrate your results on a graph of arrival error against theta. So assume that the entrance is 100 meters wide, and this is what I draw the entrance, 100 meters wide, and my ship is right here. It's heading right towards the middle of the entrance, so right like this, and there's 10 kilometers away from the entrance. So the distance from this point to the entrance is 1,000 meters, 10,000 meters, and since this is the entrance, so for the ship to arrive to the entrance, you have to at least arrive to these edge point. You couldn't get any further than that, or else you will not be able to enter the entrance. So the largest theta you can get is when you go head to the right edge of the entrance, which is 50 meters away from the center of the entrance, and this is how I make theta right here. So this is 50 meters and this is 10,000 meters, so we can make an equation. Tangent theta is 50 over 10,000, which makes theta 0.005 radian in radian. My second question is to assume that theta is 0 degrees, 1 degrees, 2, 3, 4 degrees, and plot a graph of theta in the x-axis and the error in the y-axis, which will make a equation I've previously made right here. Tangent theta equals to the error over 10,000 meters, because wherever the ship is, for instance, when the ship arrives right here, this is gonna be the error. Let's write arrow right here, and this is where the ship started, and this is the 10 kilometers it went. So I'm gonna write 10,000 meters, and this is just horizontal, and this is where the ship went. It is supposed to go straight, but it went to the right, so this is the error it made, which makes another equation. Error over 10 times 10,000 equals tangent theta, and by switching their positions, we get error equals 10,000 tangent theta. Now this is how I plot the graph. I kind of made an adjustment of the x-axis, which is supposed to be in theta radians, but I multiplied it by multiplied a constant of 180 2 pi over 180 in order to adjust it into the degree system, and this is the plot I got. So we could see that of course obviously 0 theta makes no error. 1 theta makes approximately 1 degree would make approximately 350 meters error. 2 degrees will make even larger. 3 degrees and 4 degrees will make an error which is approximately 104,000 meters, which is large enough that the ship wouldn't get into the gets through the entrance. So it also agrees to the prior conclusion we got that the arrow should be inside less than 0.05 radians, which is about let's say what's 0.05 times 180 over 2 pi. 2 pi is about 6, so 180 over 6 is about 30. So if I times this by 30, it gets 0.15 degrees. So 0.15 degrees would be somewhere here. So if you just make it bigger, 0.115 would correspond somewhere in the 50s. So it couldn't get greater than 0.15, or else the arrow would get over 50 degrees, 50 meters from the center, which is going to get the ship outside of the entrance. Thank you.